Hi, thanks for watching. So today I'm going to be working on my generative art project. Yesterday I got to a point where I've generalized the code and put it into classes, well, specifically one class. Um, and so now I could call it like in this code I have right here. So if I go back in, type some lines of code. Two-sided is the class that I made because these are two-sided shapes. I also want to make three-sided shapes, and then draw with boundary. And then the red is my boundary, and the boundary isn't very good. I guess so. The first thing I need to do is take out this line. So I added a little bit of stuff, which is just that I added the drawing of the second curve. So um, okay, so that's what it looks like. And I want it to draw the second curve. Oh, um, that's right. I want to know how to reverse a list. Oh, actually, first, real quick, I'm going to go in here and change the description of this video so that I could get more views, hopefully. So, hashtag Python, because that's my language I'm using. Hashtag, I guess, art. Hashtag, uh, electronic art. No. Oh, that's EA, obviously. Okay, Python, art, um, math. Maths has more. I'll just do maths and math. Um, hashtag coding. Coding. Hashtag project. Okay, that should be good. Take that out of there. Generative. Hashtag art. Okay. I guess. Generative art. Okay. Save. Okay. Oh yeah. And also, I want to view the comments because last time somebody left a comment and I didn't see it. So instead of watch, it's going to be /chat. God dang it. Save. Okay. YouTube view only chat for live stream. Oh. Now can I cancel out of here? Oh, very good. Okay. So I can leave that there. Now what was I doing? Guess I could get rid of my music. That's what I have. What do I want to do? Oh yeah, that's right. Reverse a list. Cool. So here points 2 will be reversed so it doesn't draw that big ugly line in the middle. Exit out of there. Open this back up. And let's see how it does. Whoop. Can only concatenate list, not none type to list. Put the debugger in right there. Alright. That was a cool shape. Points 2, and then if I try to reverse it, what? Dot reverse. Okay. I don't understand this at all. I'm gonna leave the debugger. So let's just do h equals that, then g h dot reverse g. Yeah, I don't know. Prime numbers h. If we do h dot reverse again. Oh. Okay, so I'll just do up here points 2 dot reverse. Alright. Now that should be good. Exit. Okay, very good. So this isn't, they call it a parallel curve, but it basically just gives an offset curve. Which doesn't really do anything for us. So now I'm wondering, so this is really just a polygon, because these are all defined by points. So I wonder if you can expand a polygon by a certain amount. Oh, yeah, that's what I want to do. So buffering. Okay, Python buffer a polygon. How do we do this? Shapely. Maybe this is what I want. I'm pretty sure I already have it. Yup. Shapely get buffer on polygon. Wow, they already have that. So let's look into Shapely buffer. Oh, great. Computes the buffer of a geometry is what that does. So okay, so I need to pass in a geometry object. Geometry. So I guess I want to look at some examples for this. Unless I already have polygon, which I think I do. Get point. Well, yeah. Point. Random point dot within poly. Okay, just a sec. I'll be right back. Alright, so um according to this, I can get a polygon. Just check if it's within the polygon. Poly. Oh, so you pass in the polygon. So now when I do random points within. It's a random point within the bounding box. So generate control points, random points, calculate curve points, draw shape, clear canvas, calc, get boundary. Just gonna do another one. Oh no. Oh, well, I have boundary points. Curve 1 and curve 2. Calculate, draw. So when I draw, calculate curve points, self-dot points. So I guess I'm gonna censor this and then just do this for point in self dot points self dot t dot go to point. Okay. Now running that. Oops. Should be exit. Well, that's interesting. Exit. So I think that works. I mean, obviously the red one doesn't work. So get boundary. Okay, so this will be get boundary 2. Get boundary 2. Self. I guess just get outer boundary works. So draw. So get outer boundary. The first thing we do self dot yeah. So self the boundary we have the polygon. From Shapely import buffer. Okay, now we have buffer. Now boundary self. So the shape polygon is equal to polygon self dot points. Okay, so the outer boundary is equal to buffer buffer cap style, buffer join style. Okay, I'm gonna look up another example. You do dot buffer. So it's just shape poly dot buffer. So we can take that out. Yeah, so what does this return? Returns a polygon. Okay. So it returns a polygon. Dot bounds, dot buffer. Okay, so dot exterior should be the ring around. So get boundary, draw outer boundary, get boundary, and then and here we do this. So calculate curve points if they haven't yet been calculated. Get outer boundary, so get boundary now turns into get outer boundary, draw with boundary, get outer boundary. Draw outer boundary. So we're drawing self dot outer boundary. Points. So first you go to self dot. I will say that points is equal to self dot outer boundary dot exterior. Oh man, guess I'm gonna have to figure out what that looks like. So okay, so I install Shapely first because I don't know if I have it in here. Cool. Okay, now going into Python, import Shapely, and then okay, so P is equal to polygon, and the points to the polygon are, I'm gonna make 4 of them. Oops. Points are 0, 0, 0, 1, 1, 1, 1, 0. So the unit square. P dot exterior. Linear ring. Linear ring. I don't know what the hell a linear ring is. 0, 0, 0, 1, 1, 1, 1, 0, 0, 0. So I want to figure out about linear ring. Geometry type. Dot linear ring. Okay. So dot chords. Ring dot chords. Oh, put it as a list. So list. Well, we know the type of the whole thing is going to be a list, but what's the type of the 0th element? Okay, so dot exterior dot chords and put it as a list. So dot exterior dot chords. Okay. Go to the first point. Now it's just for point and points. So that should be good. Self dot has boundary false. Self dot get outer boundary. Yep. Draw shape. I think this should be good. Okay. So let's see how it works. Okay, something wrong with getting the boundary. Oh, buffers. Missing an argument. Distance is equal to 1. Okay. Let's see what it does. Oh, terrific. Great. So now I've got a buffer. And yeah, this is just hard. Hard to think. Well, what I'm really thinking here is when I'm drawing these, this is hard because this comes to a point, and my initial thought is I'll just pick the points of the new curve, oops, from being along the buffer, but I don't think that's gonna work. I don't know why that won't work. I don't know, I have to think about it, I guess. I'll look at it again. Wow, that's terrific. So I have the point, I have the shape, draws it, gives it a buffer. I want to try making the buffer slightly bigger. Okay. So let's try distance equals 2. Wonder if there's a way to make this with higher granularity, because this doesn't look like the best. Let's see. Dot buffer, distance, quad segs. Specifies the number of linear segments in a quarter circle. So, wonder if quad segs is equal to something larger, it will look better. Oops. Quad segs is equal to 32. Wonder if that will be much better. Okay. Now if we run this one. Unexpected keyword, quad segs. Quad underscore segs. Okay. buffer. Oh. Import. So, I'm try importing this again. Before I did capital B, so maybe that was the problem. I'm sure that was the problem, but this should work with quad segs. Shape poly dot buffer, so comment out that one. Now outer boundary is equal to buffer, and okay, so I want to buffer the shape polygon, and then distance is equal to 2, and quad segs, it should be 32 segments on a quarter circle. So now let's run this. Oh, cannot import name buffer from Shapely. Shapely.buffer. From Shapely import buffer. So I'll try importing it there and then just saying so this I'll just call shapely.buffer. Now if I try to run it, oh, that works. Nope, doesn't calculate the buffer though. Shapely has no attribute buffer. I don't know why it's so hard to find this function. So yeah. Shapely buffer function. Okay. Okay. So I'm kind of confused about how buffer is done. I wanted to make okay, let's go to Polygon and look at the methods that Polygon has to offer. Um, Get a geometry that represents all points within a distance of this geometry. A positive distance produces a dilation, a negative distance an erosion. A very small or zero distance may sometimes be used to tidy a polygon. Resolution of the buffer. So maybe resolution? If quad segs doesn't work, I don't have much faith that this will work. But distance seems to work, so who knows? Okay, now exit out. Let's try to run it again. Oh, nice. So that resolution is a little bit better. Boundary, shapely, boundary, high, resolution. Okay. I don't know. I think I'm happy with this. I guess I could see if I crank up the resolution. Is there a visible difference in what happens, or does it basically just stay the same? Oops. There, it doesn't even start. Oh, and it did this thing again. I don't know why it does that. Sometimes it seems like it just can't. It just keeps failing the test of, is the area big enough? Oh, I see. I think that's because the 2 points just simply aren't far enough away. The 2 randomly generated points. Oh, so if you do a lot of points, you do get a nicer boundary. Yeah, okay. Okay, and real quick, I'm going to try to change this to 1 again. Distance should be 1. Yeah, let's do distance 1.5. just to see what that looks like. That looks better. Okay. Now, what if I don't want it to be rounded and I want it to come to a point? Okay, so then what if we do cap style is equal to square? Okay. Line buffer. Type error, wrong type. Cap style. Dot buffer, cap style. Round, square, flat. From shapely, import, buffer, cap style. Buffer, cap, style, dot square. Okay, so I could just do that. Oh, I've already imported shapely, so I could just say equals to shapely dot buffer cap style dot square. Okay, now try and running it again. Fails. Okay. From shapely import buffer cap style. Okay. Buffer cap style. Okay, take another break. Okay, now I'm back. I think I decided the buffer cap style is fine because I don't want it to be a sharp I don't want it to be too sharp of a turn. So if I make it the smooth style, okay, get rid of that. So if I make it the smooth style, then I could just take the boundary to be part of the next curve. Okay, so there it is. There's my boundary. Okay. Now the next thing I want to do, this is just hard to think about what to do next because I want to draw an adjacent shape. If I draw an adjacent shape that follows this curve, I think this area will be kind of ugly. I wonder if there's a way to find the Bezier curve, a quadratic Bezier, if I know one endpoint. Say I get an endpoint here, and I say I want the second endpoint to be somewhere over here. And I want it to go through a point. If I only know one endpoint, and I only know one endpoint and a point that the line goes through. So I'm going to look up the quadratic Bezier equation, see if that's possible. So here it is. So B of t. I guess each of these you could just treat x. This p naught is so x of t equals x naught plus t times x1 minus x naught, and p. Oh, that's linear. Given points p naught, p1, and p2. Okay, so p1's the control point. So that would be x1. So this would be known. Do we know what t is? It doesn't really matter what t is when it passes through. Find equation of quadratic Bezier given a point it passes through and a single endpoint. Can we do that? Based on its control points. So really what I want to do, I'm gonna run this again. I'm thinking about what I want to do when I draw the next curve, which is gonna be adjacent. So it draws the first curve. Now it draws a boundary. Now, my initial idea is take part of this boundary and make it the next curve. Because I want something like this curve's here, and then the next curve might start here and go down here and look like that. Man, this is just hard. Really hard to think of how to do this. So, I want a Bezier. I know a single endpoint. So, I guess that we could go into Google Docs. Okay, now I'm gonna put this over here, that one over there. What's the quadratic Bezier look like? Insert equation. So x of t is equal to 1 minus t quantity squared times x naught plus 2 times 1 minus t x naught plus 2 times 1 minus t times 2 times 1 minus t times x. So the control point, and then plus t squared times the second endpoint Alright. So if we save the t's from calculating the Bezier curves, then we can know the t associated with the point. So we know t. What we don't know is xc or x2, and we have x naught. So if we're to rearrange, we could say x of t. Okay, so new equation. X2 we don't know, x naught we know. So we could say x of t minus 1 minus t squared, that whole thing times x naught, is equal to this part of the equation over here, which actually when we simplify it's 2t x sub c times 1 minus t plus t squared x sub 2, so that's kind of quadratic. I don't really care about pulling out the t because it's already known, I think. wonder if I could pull out the t. So you basically get a relationship between x sub c and x sub 2. They have to be related somehow. If it passes through the point. Oh, I know. Use two different points that x has to pass through. That the curve has to pass through. And these two different points should be x1, p1, and p2. So, we can copy this equation, put it down here, and then put it down here again, and x of t, so this should be x1 of t, x naught stays set, x1 of t1, t1 is known, remember. We know t1, so that makes this whole thing solvable because the only unknowns are xc and x2. And now this one's solvable. Minus 1 t2 x naught 2 times t2 t squared t2. This is also t2. Okay, now we have these two equations. Now, the only unknowns on this side are that, so let's put an equation in. And now we try to solve, so x1 minus two different points. So endpoint 1, endpoint 2, x of t, so it should be endpoint end 1, and this equals end 2. So this becomes simply x1 minus that whole thing. X naught is x sub e1, t1, x sub c, x2 is x sub e1. That's a constant. Oh, but x sub e1 is not known. So if we do this whole thing, now let's do a new equation. Okay, so the left side of the equation is a constant. On the right side of the equation we have x sub c. So we can say that we could take this left side, okay, now the left side is up there. After taking that, we subtract minus t sub 1 squared times x sub e2. That should be endpoint 2. So minus that second endpoint, and then you divide the whole thing, divide it by 2 times 2t1 times 1 minus t1, and then that whole thing is equal to the x of the control point. And then so this is equation 1. It's 2 different points, so now we get equation 2 here. Okay. This gives us equation 3. Okay. And over here, finally, we get equation 4. We know x sub c well, I guess then we could just get equation 5. And let's increase that size so you can see it. Alright. X1. Now this is not X1. This one is X2. That's T2. That's the same. Okay. Now this should be T2. X sub E2. This should be T2. And this should be T2. So now we have X sub C. Plug. Set 3 equal 5. Since x sub c equals x sub c. And solve for x sub e2. So now plugging it in, new equation. We can say that this is equal to that, and now if we solve, I'll be right back and take another quick break. Alright, now I'm back. So, I'm working on solving this. How long have I been going? Hour 24. So, let's do this algebra. Set 3 equal to 5. Now, what do I want to find here? Okay, so x2 is known, x1 is known. Oh, xe2 is what we don't know. So we're going to put up here knowns x sub e2, x1, x2, oops, x1, comma, x2, comma, no, oh yeah, that is known, t1, comma, t2, do we know anything else? No, I think that's it. Okay. So, set 3 equal to 5, since xc equals xc, yeah. So the only thing to find here is x sub e2. So, the 2's should cancel. Well, let's just, yeah, let's do it out. So, this will remain on the left side. Ah, man, this is hard. Trying to figure out how to isolate those x sub e plus 2's. I guess the easiest way is to just separate out the terms. So, should be a fraction. Top term is that. Bottom term is this. What? Guess the page stopped responding. Okay, let's refresh. Okay, back into here. Now, let's copy that denominator. Whatever. 2t 2. Oh, it's being unresponsive again. Okay. So, let's put another equation in here. And the top should be this. Backslash frac. Put the top up there. Now let's get the bottom. Okay, it's unresponsive again. I wonder what the hell is happening with this. Exit. Reload. Alright, now let's get rid of that. Now, just gonna type it by hand. x2 minus quantity of 1 minus t2, square that whole thing, multiplied outside of x sub e1. Oh, no, that's good. And then the bottom is just 2 t2 times 1 minus t2. Alright, and then, so that whole term, and then minus this term, x sub 1 minus, inside here, 1 minus t sub 1, t sub 1 squared. Oh, those are two different things. Okay, so x sub c, x sub 1 minus there, t sub 1 squared, t sub 2 squared. Okay. I see, so that's in the wrong place. Okay, very good. Minus t sub 1, and then this is squared, and then outside we have x sub e1. So this is just a whole giant term, 2t sub 1 times 1 minus t sub 1 is equal to x sub e2 times and then, okay, so the inside term is just minus t sub, well, this is a fraction, minus t sub 1 squared over 2t sub 1 inside parentheses 1 minus t sub 1. Okay, and then plus, and it's just the same term except with t2's. T2, T2, T2. Alright, now, that's cool. And now we could get that second endpoint. So we're just going to say that this whole thing so insert another equation. A equals that thing. B equals this thing. And then I can say for equation 8, x sub e2 is equal to a divided by b. Cool. So I have x sub e2 then plug 8 into 5 to get x sub c. Great. So I have some control points I want. I have my endpoint. Okay, so basically what I have right now is I have some code that generates this setup. Now we want to use the red boundary to get the edge of the new curve. So I'm just debating whether I should do that now or start another live stream later to try and do that. Basically the problem is, I don't know, I think that should actually work okay. Okay, let's do let's find an adjacent shape. So create initial shape. Define get adjacent shape of self. Okay, I'm going to minimize this. Put that over there. Put this over here. Now, so I'm going to say end point 1 is equal to, so I'm going to do Python get random element from a list. Import random. Okay, now endpoint 1 is equal to random dot choice self. So I'm gonna make these that self dot points. That becomes self dot points, and this becomes self dot points. So endpoint 1 random choice. Get a random point. Point on curve 1 is equal to random dot choice of self dot points, and point on curve 2 is equal to random dot choice of self dot points. And we're gonna say if so we're gonna need to save the t's. Oh, need to save the t's that's associated with calculating the curves. Oh no. But there is no t that's associated with calculating the boundary curve. Of course. Yeah, that's kind of weird. So under np.random.random np import numpy as np np.random.random10. Cool. So segment 1 is equal to np.random. Oh, should be self dot points, and you index from np.random.randint len points. So starting index is equal to np.random.randint len self dot points. Ending index okay. Actually, I think it doesn't matter if the indices go backwards or forwards because it's just which direction it draws the line. So yeah, there's the starting, there's the ending. np.random numpy random 0 to 1. Random.uniform. Okay, so a plus b minus a self-determined. For I in range 10, print random.random. Okay, so t's is equal to np.arange. Forgot how I did it up here. So granularity. So just whole thing. So paste it in there. Should be self.granularity. Alright, now for t and t's, diff is equal to t minus np.abs, so the absolute value of t minus start t is equal to np.random.uniform. So started at a random point between 0 and 1 on the uniform distribution, then get the difference between the current time and the current t and the start t, and then can do for c comma t and enumerate. So now we get an index called c at each time. And now if c is equal to 0, here we could do if c is equal to 0, max diff is equal to diff, else if diff is less than, I'm going to call this min diff, else if diff is less than this, I guess, is 0.1t. Okay, and 0.1t, because start t is 0. So c equals 0, min diff is equal to diff, else if diff is less than min diff, min diff is equal to diff. Now, whatever the minimum difference is, and min t is equal to t, and then if diff is less than min diff, smaller, just rewrite min t is equal to t. So that gets it now 0.1t is just equal to min t. And then you could do the same thing for 0.2. Oh man, okay. Now let's think. Let's think. Okay, now, so I could say points is equal to, golly, alright, 0.1t, so we get 0.1. Now let's get 0.2t is equal to np.random.uniform. Alright. Starting index, ending index. Yeah, I'm just gonna call this starting point is equal to, and it should be a random index. Ah, man. Okay, so starting index is equal to that, ending index is equal to that. Let's just do indices is equal to this thing. So there are indices, there should be 3 of them. Should be 3 for endpoint 1, point 1, and point 2. Now, for index in indices, so we want the biggest index. So let's copy this Just gonna put it in there. Make some random points. Oh my gosh. Alright, now, so self.points, it'll just be points. Points. And points, okay. So those are the indices. For index in... Oh, man. Okay. While same is equal to... Man, I'm having trouble thinking about this. So I get the indices. Now make sure all of the indices are different. So I guess I could do while unique indices is equal to false, and first I'm gonna say unique indices is equal to false, okay, and while that's equal to false, get these, and then unique indices is equal to indices of 0 is not equal to indices of 1. So none of these could be same. So, or indices of 0 is not equal to... So basically, if one of these evaluates to... If one of these evaluates to true, then it will return true. So this should be and. Indices of 0 is not equal to indices of 2. Okay, so we already know that 0 is not equal to either of them. And then now we just want to make and indices of 1 is not equal to indices of 2. Okay, so that ensures that we are getting unique indices. Now, endpoint 1 is equal to the minimum of indices. Now, curve, I'm just going to call endpoint 1 index. Now, point 1 index is equal to, point 2 index is equal to the maximum of indices. And now, point 1 for index in indices if index is equal to endpoint 1 index, well, then I could actually say if index is not equal to n.1 index and index is not equal to 0.2 index, then 0.1 index is equal to index. Okay. So now I have the indices for each point. Alright, so okay. So I have the index of point 1, point 2, and point 3. So, or the endpoint. So I can just say endpoint 1 is equal to self dot points of endpoint 1 index. Alright, point 1 is equal to self dot points of point 1 index, and point 2 is equal to self dot points of point 2 index. Okay. So point 1 is equal to self dot points of point 2 index. So I have the 3 points. Now if I click over to here, I can get A. So point 1t okay, so there's indices. So point okay, so unique t's is equal to false, and then same thing, so just while unique t's is equal to false. Times is equal to np dot random dot uniform np dot random dot uniform yeah np dot random dot oh no, that won't work. Well, unique t's is equal to false times so basically I needed a unique time that's associated with each point. Point for time for point endpoint 0 obviously is 0. All unique t's is equal to false. T's is equal to that. So I've got indices. Now we have t's endpoint 1, endpoint 2, ending index. Okay, I don't think I need these anymore. I do need the t's. So let's go numpy get random element from array. random dot choice oh yeah, 0.1t equals that, 0.2t equals that. So then we could have diff1 is t minus 0.1t, and then diff2 is equal to the absolute value of t minus 0.2t. Okay, min diff1 is equal to diff1, min t1 equals t1. Copy that. Min diff2, diff2, t1. Oh, it's just t. And then min t2 is t. That's if c equals 0. Otherwise, if diff1 is less than min diff1, yeah, min diff1 is equal to diff1, and min t1 is equal to t1. Okay. If diff1 is less than min diff1, and so this is going to be the same thing, except with the two values. If diff2 is less than min diff2, min diff2 is equal to diff2, min t2 is equal to min t1 is equal to t. Min t2 is equal to t. Okay. And then 0.2t is equal to min t2. Now, if 0.1t is greater than 0.2t, then 0.1t is equal to min t2, and 0.2t is equal to min t1. So those are the points. Now this should be pretty easy from here. So calculate A. A is equal to x2. So A sub x is equal to end point 0.2 of 0 for x minus, and then in parentheses 1 minus 0.2t .2t is squared Okay, and then so then outside the parentheses is endpoint 1, and endpoint 1 of 0 for x, 0.2t. Okay, and that's the numerator of e, or of a. Okay, and then the denominator of a is 2 times 0.2t times, and then more parentheses, and then 1 minus 0.2t, and then that whole term, oh man, take that whole thing, subtract another term. So now it's 0.1, the x value of 0.1 minus 1 minus 0.1t quantity squared, 1 minus 0.1t quantity squared, and then on the outside you have times endpoint 1 of x. Alright, and then divide that whole thing by 2 times 0.1t times, and then inside parentheses 1 minus 0.1t. Okay, that's the a value. Now a sub y is just the same thing, but with 1s instead of 0s. So index it here, that becomes a 1. This index becomes a 1. And that index becomes a 1. And this index becomes a 1. Alright, now just have to do the b's. Okay, so b sub x is equal to, there's two terms that are added. So first term is minus 0.1 underscore t quantity squared. Okay, now divide this whole thing by 2 times 0.1t times, and then some parentheses, 1 minus 0.1t, and then plus, and then the right hand term is the same exact thing except t2 instead of t1. So 0.2t, 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 so that's b sub x don't even need to make it x because there's no x terms involved, so that's just b. And now we're gonna say endpoint 1. No, we have endpoint 1. Endpoint 2 is equal to, no, the first point is a sub x over b, and the second point is a sub y over b. Okay, nice. Now what do I have to do? This is actually just calculate endpoint 2. So I have the second endpoint. Now I want to get the control point, which is right here. So now we can say control point is equal to okay, so control point x is equal to point 2 of x, so of 0, minus, and then in parentheses, 1 minus t2, 1 minus 0.2t, squared, okay, and the parentheses, then outside the parentheses times endpoint 1 of 0 to get the x value, and then minus t2, so 0.2t, quantity squared, and then times endpoint 2, the x value of endpoint 2. Okay. Minus 2, yeah, t2 squared. Okay. Take that whole thing, divide it by 2 times 0.2t, times 1 minus 0.2t. Okay, and that's the whole thing. So that's control point x. Now control point y. So these become 1s. Okay. And then control point is equal to, that's just the x and the y of the control point. Alright. So I have the two endpoints, and I have the control point. Now this means I should be able to get the new Bezier. So calculate Bezier points, endpoint 1, endpoint 2, control point, granularity. Okay, new Bezier. Just gonna call it adjacent Bezier is equal to calculate Bezier points of endpoint 1. That's easy. Endpoint 2 and control point. Leave the granularity what it is. So that's adjacent Bezier. Assign that to self. Okay. Draw with boundary. Draw with adjacent of self. Okay. So basically, I want to do these things. all the way through to drawing the outer boundary. And then once I draw the outer boundary, I want to get adjacent shape. And then self.draw adjacent. So I'm going to call this method, which I just have to define first. So draw shape, draw outer boundary. So I guess I just need to do draw adjacent. Define, draw adjacent, self, self.has adjacent. So I'm gonna do another Boolean flag. Has adjacent is equal to, oh, I guess that's set to true once I do get adjacent shape. So then upon initialization, self.has adjacent get adjacent self.has adjacent, okay, is equal to false. Okay, so now I do if self.has adjacent is equal, so if we do not have the adjacent yet, self.get adjacent shape. So if there's no adjacent shape yet, get the adjacent shape, and then self.points. So pick up the turtle. Now we're gonna go to the first point on the curve, self.adjacent Bezier. Adjacent Bezier. So go to the first point and then put it down. No, self.t dot put down, and then self.t dot pen color. I don't know what color I want this to be. Red, light blue, green. Maybe another blue, maybe purple or something. This should be good. Medium violet red. Okay. Now for point in self.adjacent Bezier, self.t.go point. Draw with boundary, draw with adjacent, so turtle, draw adjacent, draw outer boundary, get adjacent shape, draw adjacent, and then add to the end, exit the screen. When it clicks. Okay. So now to see if this works, exit, So draw with boundary, draw with adjacent. Okay, there's the boundary. Bad color string, medium violet red. Oh. Okay. Now can exit. Okay, drawing the initial curve, filling it in, drawing the boundary. Now the Bezier. Well, okay, I'm gonna make these points so that we know the points that it's trying to draw. So draw with adjacent. Endpoints. Self dot endpoint 1 is equal to endpoint 1. Self dot endpoint 2 is equal to endpoint 2. And self dot control point, and all these are gonna be adjacent. Okay, so then when we draw it, draw with adjacent, draw adjacent. So draw adjacent. Self dot t dot pick up. So pick up the turtle. Now self dot adjacent endpoint 1. And then I want to do a dot. So exit list code. Oh, I think there's another VS Code window. Yeah. So generate random shape, go to point and then dot and then 20 and then the color. So go to self dot t dot dot 20 blue. Gonna do this again. Self dot t. So pick up the turtle now. Put that in there. Adjacent endpoint 2. Then pick up the turtle again. And now adjacent control point. And then that dot should be green. So control point's green, adjacent points are blue. Now that quick because it was too small again, so okay, draws the shape, draws the border, or I forgot the word, buffer around the shape. Okay, so cool, at least it's drawing the curve the right way. I'm not sure how it ended up with those points. And I'm going to leave it here. and leave this to work on the next time, because my mission here was just to get the buffer, which I successfully did. So go to notes. Still need to develop the technique for fitting shapes together. Now when completed, I can do draw buffer around single shape. And now I've, oh, well that's completed. So now what I want to do is troubleshoot getting adjacent Bezier. I guess well, okay, if I start troubleshooting now, I know the first problem, which is the second endpoint isn't on the boundary. First endpoint's on the boundary, second endpoint is not on the boundary. So where does it get that second endpoint from? Second endpoint. Draw adjacent. Okay, so adjacent endpoint 2. A sub x over b. Okay. So endpoint 2 is being calculated incorrectly somehow. So that's where I'm going to start when I work on that. Endpoint 2. I know that endpoint 2 is being calculated incorrectly because it does not. I know that endpoint 2 is being calculated incorrectly because it does not lie on the boundary -- buffer. Okay, so that's what I'm gonna do next time. Thanks a lot for watching. Have a nice day.